exclusive tutorials, the best online academic platform for all science students preparing for JAMB, WAEC, and post-UTME. Now, today on today's video, we're going to be treating laws of gases in your chemistry. We're going to be treating laws of gases, your Boyles law, your Charles law, your general gas equation, and the rest of it. Now, introducing us to gases, there are some things I want us to know. Whenever we talk about gases, there are some things you need to know. Gases, talking about gases, it has to do with their pressure, has to do with temperature, it has to do with their volume, and we can say mole, or we can say mole number. Just leave it as number of mole or mole number. Now, for you to be able to solve or do all calculations involving gases, you have to be aware of these four major things: your pressure, your temperature, your volume, and the number of mole. Now, you need to understand the how we calculate for pressure, how we calculate for temperature, the volume, and the rest of it. Now, we're going to be looking at these things one after the other and their values. Now, talking about pressure, when you are calculating for pressure, pressure has to do with ATM. Then, when you are converting your ATM, 1 ATM to millimeter mercury is equals to plus 160. You add 760 to it, which is 1 ATM is equals to 760 millimeter mercury. The same thing, 1 ATM is equals to 760 torr, which means 1 millimeter mercury is equals to 1 torr. You have to take note of these things for you to be able to calculate anything on pressure. Now, one other thing you need to understand about pressure is your Pascal. 1 ATM is equals to 101,325 Pascal. Pascal is written as a TA. Now, that is that for pressure. Now, for temperature, temperature is calculated in your degree Celsius. Okay, let's use here for temperature. Your temperature, T, is calculated in degree Celsius. Now, and also is calculated in Kelvin, degree Celsius and Kelvin. Now, 1 degree Celsius is equals to 273 Kelvin, which means that if you are giving anything in degree Celsius, to convert it to Kelvin, you are adding 273 to it. Now, talking about your volume is calculated in CNQ or DNQ. Now, converting from DNQ to CNQ, you add 1000 to it. Converting from CNQ to DNQ, you subtract 1000. Then we know our number of moles. Now, let me give us some questions regarding conversion from pressure, in pressure from ATM to millimeter mercury, from ATM to torr and Pascal and the rest of it. Okay, now let's come to this side of the board. Okay, let's say for example, you are giving your pressure. Let's say you want to calculate for the pressure of a gas, and you are giving your pressure in let's say you are giving your pressure in millimeter mercury. Let's say you are giving pressure in millimeter mercury, and you are asked to convert this, let's say 30, convert to, let's say 1, convert to torr. The second one we're asked to convert to ATM, and the third one we're asked to convert to Pascal. Now, what do we do here? Just like I told us, I made us understand that 1 ATM of your pressure is equals to, Okay, here we are giving a millimeter mercury, right? Is equals to 760 millimeter mercury. Now converting, now that we are giving 30 millimeter mercury, and we are going to convert it to ATM. Okay, the first one is converting to torr. Okay, let's solve the first one first. Converting to torr. And we made us to understand here that 1 ATM is equals to 760 millimeter mercury, and as well 1 ATM is equals to 760 torr, which means that 760 millimeter mercury is equals to 760 torr, 1 millimeter mercury is equals to 1 torr. So when we are converting 30 millimeter mercury of pressure to torr is equals to 30 as well, since we have this is equals to this. Now the second one asks us to convert to ATM. Okay, now the second one asks us to convert to ATM. Since 1 ATM is equals to 760 millimeter mercury, and now we are having 30, which means that if 760 is equals to 1, we are going to have that 30 is equals to 30 times 1 divided by 760. And by the time you punch that in your calculator, having 0.04, which means we have successfully converted this 30 to 0.04. How about the third one, which asks us to convert to Pascal? Let's use somewhere here to convert to Pascal. The third one said we should convert to Pascal. Now converting to Pascal, we made us understand that 1 ATM is equals to 101,325 Pascal. You getting it? Now we are giving these as 30 millimeter mercury, and remember we are converting to Pascal. We have succeeded in converting this 30 millimeter mercury to ATM here. Remember this one is in ATM, right? This one is in ATM, right? Which means that if 1 ATM is equals to 101,325 Pascal, 0.04 ATM will be equals to 0.04 times 101,325. This is 3 divided by 1. Because we have already converted to ATM already before getting 4,053 Pascal. So we have succeeded in converting our pressure in millimeter mercury to torr, to ATM, and to Pascal. Now by watching this, I understand that you should be able to convert this. Okay, now let's take a conversion on temperature. You know, we made us understand that our temperature is in degrees Celsius and our temperature is in Kelvin as well. Let's talk about temperature conversion. Temperature conversion. Okay, now let's say for example we have, now note, when you are calculating during your calculations in temperature, most times you calculate your temperature in Kelvin, in your Kelvin scale. Now let's say for example you are going to solve a equation on any of the gas laws or any of the gas equations, and you are giving your temperature in degrees Celsius, and you need to convert it to Kelvin. Now note, when you are giving your temperature in degrees Celsius and you are using the normal formula, let's say for example you are solving for Boyles law or Charles law, and you are using that degrees Celsius volume or value to calculate, imputing it in your equations, you are going to get totally the wrong answer, because you are expected to convert to Kelvin scale first before your calculations. Now let's proceed. Let's say for example you are giving your temperature to be 30 degrees Celsius. This one I'm using 30. Hope there's no relationship between me and 30. Now let's say for example you have 30 degrees Celsius and you have to convert to Kelvin before your calculation. Now to convert, remember I made us understand that 1 degree Celsius to convert to degrees Celsius, what you do is just to add 273, which is to say that 0 degrees Celsius will give us 273 Kelvin. So to just convert, just say plus 273. And if we decide to add up this, 30 plus 273 will give us 303 in Kelvin. Now let's say for example, we are giving our temperature in Kelvin to be minus 30. Convert minus 30, sorry, in degrees Celsius, and you have to convert to Kelvin. The same way, add 273 to your minus 30 in degrees Celsius. And by the time you add it up, I think you're going to be having 243 Kelvin. Now, how about we are giving in Kelvin and we want to convert to degrees Celsius? Let's say, for example, you are giving Kelvin to be 293, your temperature T, 293 in Kelvin, and you have to convert to degrees Celsius. Convert to degree Celsius. What do you do? If to convert from degrees Celsius to Kelvin, you are adding 273 to it. It means that the opposite becomes the order when converting from Kelvin to degrees Celsius. So what do you do here? Since you have your temperature to be 293 in Kelvin, what you're going to do is to subtract 273 from this, you get your answer. So what you do is 293 minus 273, and what you're going to get there is 290 and 3. I think you are going to be having 20 degrees Celsius. I think this was helpful to us. So here we have treated, introduced us to our gas laws, introduced us to all the laws of gases, introduced us to pressure, the temperature, the volume, and the mole, and everything we're going to be using for our calculation. Now, right now, we are going straight to some major equations or some major laws of gases. Now, first of all, let's start with your Boyles law. And starting with, we're going to be treating Boyles law. Now, let's take the definition first, then we'll look into some calculations and how to solve equations or questions involving Boyles law. Now, Boyles law made us to understand that at a constant temperature, now, what does it mean is that when your temperature is constant, let's say for example, at a constant temperature, 37 degrees Celsius, without changing it, it made us understand that the volume of a gas is inversely proportional to the pressure that passes through it. Now, let's say for example, this is your volume of a gas. It making us to understand that the volume is inversely proportional to the pressure that passes through it. Now, this law makes us to understand that since volume is, inversely proportional to pressure, it means that when volume increases, the pressure is reducing. And when pressure increases, the volume is what? Reducing. Now, this is what Boyles is trying to talking about. Remember, at constant T, which is your temperature. Now, we are going to use this definition that Boyles is explaining to solve questions involving Boyles law. Now, what this means is that at constant T, it means that if V is inversely proportional to P, it means that where T is a constant, it means that V1 is equals to P1. Now, when you bring this proportionality down, it means that T is equals to V1, P1. That is why when we are solving equations of Boyles law, we use something like this. V1, P1 is equals to V2, P2, etc. Now, let's use this idea to solve this question now. Normally, on solving questions, how we derive it, how we derive it does not really matter, but bear this in mind whenever you see questions involving Boyles law. V1, P1 is equals to V2, P2. Then remember what it means, so that in case they are giving theoretical question that has not to do with calculation, just know that Boyles is trying to let us know that when volume is increasing, pressure is reducing. That is why it's inversely proportional. Now, how do you know, first of all, if a equation is coming from Boyles law, coming from Charles law, or coming from general gas equation? Remember the definition here. This definition will give you an idea on how to know if this question is from Boyles law. Remember we said that T is constant. Now, let's look at this. A gas occupies 20 cm cube at 510 millimeter mercury. Now, remember, they didn't tell us that this gas, this one stands for volume. They didn't tell us that this one stands for pressure. If the temperature is constant, now let's read again. A gas occupies 200 cm cube at 510 millimeter mercury. If temperature is constant, what will be its pressure when the volume is increased to 131 cm cube? Now, when temperature is constant, what does it mean? It means that we are talking about Boyles law. So that means this question is from Boyles law. Now we have been able to know this. Now the next thing that you know how to know question from Boyles law is this. Remember I was telling us units for pressure. I told us we use torr, we use pascal, we use atmosphere, which is ATM, and we use millimeter mercury. Seeing this millimeter mercury should be enough for you to know that this value here is for pressure, and since CMQ here is enough for you to understand that this value here is for volume. Are you getting it now? Let's solve. We have made us to understand that V1, we have made us to understand that V1, I'm coming, let me use this place. We have made us to understand that V1, P1 is equals to V2, P2. Now let's bring out our values. V1 is what? 200. V1 is equals to 200 cm cube. P1 is equals to 510 mm mercury. And we are not what will be the pressure, which means P2 is unknown. P2 is equals to unknown, and volume is increased to 131. V2 is equals to 131. Now bring out this. V1 is equals to what? 200 times P1, which is 510, is equals to V2, which is 131, times P2, which is unknown. Now, which means that P2 will be equals to 200 times 510 all over 131. Now, punch your calculators and bring out your answer. Give us 778.6. So your P2 is equals to 778.2. Now, assuming that we are giving, okay, let's change this question here. Now, here we are told that what will be its pressure when the volume is increased to 131. How about, let's change this English here. What would be the pressure when the volume is increased by 131? Now, some of the problems that we face when calculating chemistry questions is that you have to understand the question, you have to read very well. Now, the first thing we'll solve here says when the volume is increased to 131. But this other one says when the volume is increased by 131. Now, let's solve. Let's look at our parameters again. We'll know that our V1 is equals to 200. Let's follow up. P1 is equals to 510. Our P2 is unknown. Our V2 is increased by 131. Increased by 131. What does this mean? It means that we should add this 131 to our V1. What will be this pressure when the volume is increased by 131? Which means we're going to say 131 plus 200. Which was our volume 1, which will give us 331. Please note this. So, which means our V2 will be 331. Now, let's solve. We have 200 times 510 is equals to 331 times P2, which is to say that P2 is equals to 200 times 510 all over 331, which will give us 308. Now you see how understanding question matters a lot. The first one was 778 778.6. This one is 308. What change here was the English? Changing to die. Now let's take another question from this same question that we were given. Now let's take another question from this same question that we were given. Okay, let's say for example a gas occupies 200 cm3 at 510 millimeter mercury. If the temperature is constant, now what would be its volume? Let's solve for volume this time around. Let's solve for volume this time around. Volume. If the pressure is increased, by 101,325 Pascal, if the pressure is increased by this. Now, let's look at our parameters. We have that our V1 is equals to 200, our P1 is equals to 510, our V2 is unknown, our P2 was increased by 101,325 Pascal. Now, remember, our pressure is in millimeter mercury. Our volume is in cm3. Now, what do we do? The first thing we do is to convert this Pascal to millimeter mercury. Remember, I was teaching us in our first video, I was explaining to us how to convert from Pascal to a millimeter mercury and the rest of it. If you have not watched that video, just make sure you go back and watch it now. Now, what do we do? If we know that 1 atm is equals to 760 millimeter mercury, and also 1 atm is equals to 101,325 Pascal, which means that 760 mm mercury is equals to 101,325 Pascal. Which is to say that our pressure was increased by 760 millimeter mercury. Hope you understand. Because 1 atm is equals to 760 millimeter mercury and 1 atm is equals to 101,325 Pascal. Pascal is PA. So which means 760 millimeter mercury is the same thing as 101,325 Pascal. So which means that our pressure was increased by 760 millimeter mercury of the first pressure plus 510. Hope we are getting it. Which is equals to 1,270 mmHg. Now this is our P2. Now what we will do here to get our V2, we will now say our V1, which is equals to 200 times 510, is equals to V2 times 1,270, which means that V2 is equals to 200 times 510 divided by 1,270 equals to 80.3. So now, just know how to convert from one unit to another in all of these and understand what each gas law is talking about. Remember, I told you, let's just do a recap. I made us to understand that Boyles' law states that at constant temperature, the volume of the gas is inversely proportional to its pressure, which means that when volume is increasing, the pressure is going down, and when pressure is increasing, the volume is going down. Now, I made us to understand that the formula to solve for Boyles' law is your V1 P1 is equals to V2 P2, and I made us to understand that we should know how to convert from one unit to another when solving. Now let's go straight to solving questions on Charles' law. Okay, now let's move straight to Charles' law. Now we treated Boyles' law earlier. Now let's do Charles' law. Now Charles' law states that pressure. Remember, Boyles' law talked about constant temperature. Charles' law states that at constant pressure, when pressure is constant, which means we are using a particular pressure. If we are using 760 millimeter mercury, it should be constant. It should not change. It should not fluctuate. He said the volume of a gas is directly proportional to its temperature. Now, what does this mean? It means that when the volume of a gas increases, the temperature increases as well. And when the temperature increases, the volume increases as well. It's directly proportional to its temperature. And this means that volume is equals to constant times temperature, which means that constant is equals to volume all over temperature, which means this is equals to V1 over T1 is equals to V2 over T2. This is what Charles' law is all about. Just have this equation on your head. Once you have this equation, you can solve every problem on Charles' law. Now let's look at this. A fixed mass of gas. Remember, I've told you how to know where equation is coming from by looking at the parameters that you will be given, or looking at the things that you were given, the gases that you were given, or the properties of gases that you are given. Now, a fixed mass of gas, volume 546 cm cube at 0 degrees Celsius, is heated at constant pressure. Remember, constant pressure. What I told you here, constant pressure. What is the volume of the gas at 2 degrees Celsius? What is the volume of the gas at 2 degrees Celsius? Now bring it back. This is our formula. V1 over T1 is equals to V2 over T2. We have that our V1 is what? 546. Our T1 is 0 degrees Celsius. Now remember, I told us how to convert from degrees Celsius to Kelvin, because we are going to be using Kelvin in calculations. I said you should add 273 to it to give you Kelvin, which means that our T1 is 273 K. 273 plus 0 is 273. Then our V2, what is its volume, is unknown. Our T2 is equals to 2 plus 273. 2 plus 273 is equals to 275. Now let's solve up here. Say that 546 over 273 is equal to V2 over 275. Now by the time you cross multiply, you will know that V2 is equals to 546 times 275 all over 273. Because V2 is equals to 247.8. This is your V2. Now let's say, for example, just like I told us, if a fixed mass of gas of volume 546 is heated, okay, let's say, what is the volume? If the temperature of the gas, let's just do the way we did it the other time. What is the volume if temperature is increased by 93 Kelvin? Remember, the first temperature is in degrees Celsius, the second temperature is in Kelvin. What will be our volume this time around? Now let's go back and solve. Remember your conversion once more. Now let's go back and solve. We have that our V1 is equals to 546 over our T1, which is equals to 273 times is equals to V2 over, now we know that our V1 is 273. Now we said if the temperature is increased by 93 Kelvin, which means you add 93 to this. You understand? If it's increased by, which means you are adding this to what you have in your first volume. Now by the time we add 90 plus 70, we are having 160, which means 3 plus 366, which means our T2 is equals to 366. Therefore, it means that V2 will be equals to 546 times 366 over 273, which means V2 is equals to 732. Remember CMQ. So when it comes to Charles law and Boyles law, have these two formula in your head. That Boyles law talks about V1, P1 is equals to V2, P2 at constant temperature, while Charles law is V1 over T1 equals to V2 over T2 at constant pressure. Now, thank you for watching, and don't forget, this is explicit tutorials. We are here to make sure that academic is easy, is interesting, is entertaining, and is fun for you. And don't forget, our JAM class is currently on. Registration is still on for our JAM classes, 3,000 naira monthly, or you can purchase our exclusive JAM course, which is on seller.co. You can contact us or use this link to purchase the course. The course is 5,000 naira. Well, if you are joining us for the first time, make sure you subscribe to this channel and make sure you share this video to all your friends that are writing JAM, writing any common entrance exam in Nigeria, to any school, to any university, and make sure you keep reading and you keep loving explicit tutorials. Bye. We love you.